Hey folks, thanks for coming back to stick with us. We're talking about converse, inverse, contrapositive, and biconditional statements. So this is a extension of our previous video where we were talking about conditional statements. These are all going to be different forms of those conditional statements. So let's talk about our first one that we got here. A converse is a statement that reverses the hypothesis and the conclusion of a conditional statement. So over here I give you a conditional. It says if two lines intersect to form right angles, then they are perpendicular. So for the converse, we switch the if part with the then part. So this converse would be if two lines are perpendicular, then they form right angles. So all we did was we switched all the information from the if over with the information with the then. Okay? All right. Now our next one is still manipulating it, but it's a little less switching, a little more adding things. The inverse is a statement that negates the hypothesis and conclusion of a conditional statement. So negating something, that's saying the opposite of what's there. So if two lines intersect to form right angles, then they are perpendicular. What we're going to be doing is we're going to be introducing the word not into this statement. So if two lines do not intersect to form right angles, then they are not perpendicular. Now keep in mind as we go through these manipulations, some of these will sound a little bit funky, and we'll get into whether or not those are true or false later. Okay? All right, next one we got is contrapositive. Contrapositive is a statement that negates the converse of a conditional statement. So this statement here, contrapositive, has us taking what we had for the converse and taking the inverse of that. So it's kind of like what we did here. We put the nots in, but this time we're putting the nots into this statement. So this statement's going to be, if two lines are not perpendicular, then they do not form right angles. So all we did is we took this statement that we had for the converse and we introduced not into there. So I'm basically making whatever was there the opposite. All right. So let's get into our next bit of information. Now this next statement is going to change up things a little bit, so I don't want you to worry. All right. Before we get into this, you might already have this on your paper, but I always want to make sure that I go through and do my due diligence. When we write this up in symbol notation, we have our statements, our hypothesis and our conclusion written as P and Q. And I want to make sure you know what this would look like if we wanted to shorthand this. A regular conditional is P pointing to Q. So P is your if, Q is your then. The converse switches around your P and your Q. So it's Q going to P instead. The inverse is just like how we have for the conditional, but this time we have this symbol here. This symbol here is the not symbol when we're talking about these types of statements. Now, our last one that we have is us taking the stuff that we have for the converse and putting the not symbol again, aka not Q, pointing to not P. All right, keep that in mind. There might be questions in the future that'll go through and have you working through it symbolically or going through and working it out with words. So just keep it in mind as we go through the rest of these things. All right, last new statement that we're dealing with is a biconditional. This one changes up things a little more than the previous ones. This statement connects the hypothesis and the conclusion of a given conditional with the phrase if and only if. So this is like a super conditional statement. One thing has to go to the other thing. So it starts off, if two lines intersect to form right angles, then they are perpendicular. What we do to switch this up is we're still talking about lines intersecting to form right angles being perpendicular, but this time we make it real exact by saying, if two lines intersect to form right angles, if and only if they are perpendicular. So what we did is, instead of it being an if then, right here in the middle, this if and only if does the heavy lifting for this statement, basically linking what this information is here to this information here. All right. So if you see that, always know if and only if that's a biconditional statement. So, a couple things that are important for us to know about the truth value of these sentences. Not every single statement that we manipulate with this is always going to be true. So, if you have a conditional statement, it and its contrapositive are either both going to be true or both going to be false. Likewise, the converse and the inverse statements are either both true or both false. So if one of them is going to be false, the other one's going to be false. If the other is true, so will the other be. Okay? Keep that in mind if you ever have to go through and judge the truth values of sentences. All right. Over on the right side of your paper, we got a little bit of practice for us. So we have a statement and its respective forms that we want to link up. So if you want to pause it and try out linking up which ones are which, you can go ahead and do it. Otherwise, you can roll with this. All right, give it a try. All right, if you paused it, big ups to you. If you're staying with us, I appreciate you staying with us. So, our original statement says, if a triangle has a right angle, then it's a right triangle. So, our first one, the converse, switches the if and the end. The if and the then. So it would be if a triangle is a right triangle, then it has a right angle. All we do is switches the if and the then. Our inverse puts not into the original sentence. So this one would be our one on the top. If a triangle does not have a right angle, then it is not a right triangle. Next one, we got contrapositive. We're taking the not version of our converse. So that one would be this one right here on the bottom. If a triangle does not have a right, if a triangle is not a right triangle, then it does not have a right angle. And then biconditional is usually the easiest to see because it has that main tell, if and only if. So that's the one right there. All right, people, at the bottom of this, you got a conditional statement that you have to go through and write up with the respective forms, and then you have to decide whether each form is true or false. I'll give you a second for you to figure that out. Pause it, come back, and let's see if this works. All right, if you paused it, big ups to you. If you didn't and you wanted to just plow through, that's cool. All right, let's get into this last one. It says, if you play basketball, then you are an athlete. So we're going to write the converse, the inverse, and the contrapositive, and then decide if each thing is true or false. All right, first one we got is our converse. If you are an athlete, then you play basketball. That's false. You could play football, you could play baseball, volleyball. There's plenty of other examples. So we have to look at the statement and judge whether or not this is true. All right, next one we got is our inverse. It says, if you do not play basketball, then you are not an athlete. This is also false. You could be playing football. So again, if there's other examples that'll prove that this statement is false, that means that you got to go through and say that it's false and give that example. All right, last one that we got is our contrapositive. It says, if you are not an athlete, then you do not play basketball. This is true. If you're not playing sports, you probably don't play basketball. That's all right. That's a normal statement. You don't have to worry about that too much. All right, people, thank you for sticking it out with us. Get this glued up into your book. Peace out. Have a good weekend. Have a good night. Whenever you're looking at this, you'll be all right. Let me know if you got any questions in the comments. See you later.